Hello Internet, welcome to another tutorial in Data and Communication Networks. In this tutorial we'll discuss Hamming codes. Please understand, Hamming code is one such code that detects and corrects the errors in any transmission system. Obviously we'll use Hamming code's algorithm at the receiver end to find out error and then to correct errors. Now please understand, just like any other coding technique, Hamming code will also attach some extra bits which are known as overheads to the payload, which is simply known as the data that we wish to send. So those redundant bits, in case of Hamming code we call them redundant bits, are added to the information carrying bits of data transfer. They are also known as the parity bits. I'll talk about the algorithm first. This is one of the most intelligent algorithms designed to find out the error and then to correct it. There is a formula to find out the redundant bits, which is something like this, where R is redundant bit, M is the data bit. Suppose the number of bits that we wish to transmit are 7, then the number of redundant bits can be calculated using the formula and they come out to be 4. Now, for that being said, for example, we take up the case where data bits that we wish to send are 7 and corresponding to 7 data bits will have parity bits coming out to be 4. So all in all we'll send 11 bits, where 7 bits are going to be payload and 4 bits are going to be the overhead, which is not a very good ratio, but anyhow, journal algorithm of Hamming code. Before we proceed on to the general algorithm of Hamming code, we must understand that we have two different types of parities here: even parity and odd parity. Even parity means that we'll count the number of ones, and if the count is odd, then for odd we set it to 1 and for even we set it to 0. The number of ones, of course, we'll count them. And for odd parity, if the number of ones come out to be odd, we'll assign the parity bit as 0, and if they come out to be even, then we assign it as 1. So that are the two types of parities which are used in Hamming code, but I'll take up an example with even parity. So once you are through with how many bits you wish to send, you need to assign bit positions. So we wish to send 11 bits now, 7 data bits and 4 parity bits. Where will you fit the parity bits is one big question. So all the bit positions that are power of 2 are marked as parity bit. And the key point here is we'll start marking our bits from 1 onwards. Please do not do the mistake of starting the bit positions from 0. We need to start it from 1. And all the powers of 2, let's start from 1, 2 and 3. In this case we are sending 4 parity bits, so this is going to be 1, 2, 4 and 8. So what I'll do is I'll simply write this as P1, this is P2 and this is P4 and the next one is P8. So that is how you label the parity bits, and the rest of the 7 bits will be those data bits that you wish to send, and you label them as D3, D5, D6, D7, D9, D10 and D11. Now we need to make pairs. In the second step we need to form pairs. In those pairs each of the parity bit should be included or covered. That's the key point here. So if you wish to make pairs for parity 1, then the rule is that parity 1 covers all the bit positions whose binary representation includes a 1 in the least significant position. So I'll repeat again, if you wish to include parity 1, you'll need to include all the bits which have a 1 in its LSB, and having a 1 in the LSB means that the number is odd. Please be aware that when the number is odd, the least significant bit is 1. So the first pair will become of that of 1, 3, 5, 7, 9 and 11. And the second parity bit covers all the other bit positions including itself whose binary representation includes a 1 in the second position from the least significant bit. I'll write down a note here. The LSB should be 1, and for the second group that we wish to make, the second bit from LSB should be 1. So when you start to calculate it, it comes out to be 2, 3, 6, 7, 10 and 11. So you need to be very good at binary representations of the bits. That's what the idea is. And third group, of course, will contain parity 4 bit will contain all those other bits which have 1 in the third position. So third bit, obviously starting from the LSB, so this one should be 1. So they'll be like 4 to 7, 12 to 15, 20 to 23, etc. So all these numbers. So 4, 5, 6, 7 along with parity. So in our case, specifically in our case, it will be this group will include 4, 5, 6 and 7, because all these numbers have 1 in their third place. And the parity bit 8 covers all the bit positions which have a 1 in the fourth position, 1 in fourth position. So that means we have grouping of 8, 9, 10, 11 here, up to 15 if the case may be. So let's take up an example here. Suppose the data to be transmitted is 1, 0 1 1 0 0 1. So we can easily now at the transmitter end, what we need to do is we need to place 1 here and a 0 here and a 1 here, taking reference from here. This should be left open for parity, then a 1 here and a 0 here and a 0 here, and this should be left for parity and a 1 here. And I'll mark this as P8 as we did earlier, P2 and P1. So now we need to determine the parity bits. So first case is when we'll check 1, 3, 5, 7, 9 and 11. So 1, 3, 5, 7, 9, 11 means we include this one, then position, I'll mark the positions here, 1, 2, 3, 4, 5, 6, 7, 8. So I'll put up 11 is 1, 9 is 1, 7 is 1, then 5 is 0, 3 is 1, and then this is parity, and this needs to be calculated. Now we need to make it as even parity, so we have 4 1s here, so we should keep it as a 0 to keep the number of 1s as even. So this parity bit gets a value of 0. So this grouping is important. This grouping is grouping to determine P1. Similarly, we need to see the grouping of 2, 3, 6, 7, 10, 11 as mentioned here to calculate parity 2. So what I'll do is I'll write down 11 is 1, 10 is 0, then 7 is 1, 6 is 0, then 3 is 1, and parity is what we need to calculate now. So it has 3 1s and we need even number of 1s, so we must keep this parity bit as 1 to maintain consistency of even parity in all the groups. So I'll make this bit as 1. So next we calculate R4 or parity 4, sorry. For that the grouping will be 4, 5, 6, 7 as I explained here. So 4, 5, 6, 7 is P4 0 0 1. So the number of 1s is 1 here. It will stay even if I make P4 as 1 to keep it as even. Then finally we have fourth group, which is 8, 9, 10, 11. So we have 1, 0, 1. So if I keep this as 0, the P8 should be kept as 0 to maintain even parity. So I found out all the parities. So this is 0. I need to make this as 1, P2 as 1, P4 as 1, and P8 as 0. So the total data that we'll send is 1 0 1 0 1 0 0 1 1 1 0. So that becomes the total final data that we'll send. It will be sent as a Hamming code. this includes this bit, this bit, this bit, and this bit as the parity bits. And similarly, if anything goes wrong out of these bits, you'll not be able to calculate even parities in these groups. So on the receiver side, you'll find parities of the groups, and the parities of the groups should be even, and you would not find them even if any of the bits will change. So this is an intelligent code to determine error and detect error and correct it also. In the next tutorial, I'll take up an example of a code word received at the receiver, and we'll find out if it has error or not. Thank you so much for watching this video. If you liked the content of this video, click on the like button and consider subscribing the channel. You have a good day. Bye.